Okay, so here's the last part of this walkthrough. It's called Abstract RGB Composites. And this is going to go over the last two sections in the chapter. Section 5 tries to introduce you to additive color. We've already talked about it a little bit in the previous um, part of this walkthrough. But it's a short little theory section that's just trying to introduce how additive color works. And then section 6, it's called attributes of locations, but the idea is that we're going to show how you can use additive color to visualize change over time. So the main idea there is that this underlying raster model of representing um, different attributes of a location as bands in an image that you can then display with additive color is quite powerful and has many applications beyond just displaying different combinations of the electromagnetic spectrum. So in this case, we're going to use it to kind of look at change over time, and we'll get there in a second. But this is the figure that is in the book about additive color. And it again is kind of trying to introduce how you get these colors at a pixel based on the combination of values that are stored at that pixel. DN is digital number, but it's kind of the same thing as a pixel value. And then here's the order where the first band we're using the red channel, the second band we're using the green channel, and the third band we're using the blue channel. So what this is showing you is that when the data value, pixel value in band 1 is high, but low in the other two, because we're using the red channel to display this data value, we get red. This is how we get green. This is how we get blue. We get yellow when the data values are high in the first and second bands. So red and green combine to make yellow. We get cyan when the data values are low in 1, but high in 2 and 3. So green and blue make cyan. And then we get magenta when the data values are high in 1 and 3, but low in 2. So blue and red combine to make magenta. And when the data values are high across the board, we get white, right? So that's what this chart is trying to show. And then I've also made this this interactive app that allows people to kind of explore it if you want to look at red versus kind of the yellow, and then there's white, and then how you can get different kind of combinations of these. These sliders are basically just giving you an interactive way to kind of explore color that's outlined in the static form on this map or on this figure. Okay, so then let's go to the code here. This is a link is going to take you to the third checkpoint. So if you're using the repository, it's going to be F1.1 checkpoint. But that link is going to take you right to this. And I'm going to once again comment out, because you'll notice that when there's a lot of images being drawn now, and it takes some time to kind of draw those images. So I'm going to once again put the cursor at 11 and then push, push, push to about 88. Hold the shift down, click 88, command slash, because I'm on a Mac. If you're on a PC, control slash, and then run it again. And we should only get 2 images at this point. And actually, you know what? We don't need this one at all anymore. So I'm gonna comment that out. Shouldn't matter, but anyway, I'm gonna comment that out as well. And then here we go. So we're doing a few things here, and I'm gonna start by putting the cursor at 95, or I'm not gonna start, I'm gonna continue by putting the cursor at 95, hold shift down, click on 134, command slash. So we're just going to run these 4 lines right now. We're going to load a 1993 nighttime lights data set from its Earth Engine ID. So to look at this, this is an image that's coming from this collection. So I'm going to put my cursor at the end of that slash there before the F1093, and then hold shift down and click there. right at the N, and copy that, go up here and paste it, and there's the nighttime lights data set. So we're going to use this data set. It's the from the OLS. It's a defense program that it was originally designed to detect weather systems for military purposes, and it turned out to be really good at picking up nighttime lights. And these are the bands that are available. So in our tutorial, we're going to wind up using the stable lights, and you can see that the minimum to maximum, the data range that are stored in these bands go from 0 to 63 for stable lights. So then if we print out, when we run this line is going to print this label, nighttime lights, and then that image that we just grabbed, and that's shown over here. And so there are those 4 bands that we just looked at. We're going to wind up using the stable lights. And then here are some more, we don't have to worry about the properties, but we're going to, this is just allowing us to inspect this and basically see the bands that we're after. So then I'm going to click, shift, click, so 103 to 95, command slash, control slash if you're on Windows, to uncomment, and then click run. And so here what we're doing is saying, please add the following as a layer on the map. We're going to grab the lights 93, which is this image that we've just loaded, and I want to visualize this band, stable lights, and stretch our grayscale palette from 0 to 63, and then call this thing lights. And the result is this black and white image that shows nighttime lights, the average intensity of nighttime lights that are stable. So it's a kind of remarkable image. So stable lights means that lightning flashes are not going to be considered here. Wildfires are not going to be considered. Anything that is does not appear over the year, it's not a stable light, is not included here. And so we get this kind of remarkable image of the world that we would never really be able to see without in the real world, right? Because we've got night completely covering the planet. There's no daylight on the planet. There's no clouds. There's no wildflowers. There's no lightning. It's just this very abstract view of the world that we're going to work with here. And so the next steps are what we're going to do here. I'm going to uncomment line 105 to 107 again by just clicking shift down, click, and then command slash. So we are going to construct another image. So we called that one lights in 93 because this one is from 1993, which we can see here. And this one is going to be from 2003. And we're going to select just the stable lights, and then we're going to rename that, that band 2003. So I'm going to run this, and not much is going to happen, but here I'm going to add a piece of code and say print lights 03 so that you can kind of appreciate what just happened there. And so what we did the first time around is we loaded this image, and we did not select a band, and we did not rename a band. And when we print it out, we get this image that has 4 bands in it. What we've done this time around is we've constructed an image from this address, given it this name. So it's a different image from the collection because it's from 2003. That one's from 1993. But we've also said, please select this band, stable lights, and then please rename this band 2003. So when I look at it, when I print it to inspect it, what I have here is just an image that has a single band, and that single band is called 2003. And so if we just look at this a little bit more, just to kind of step through and understand what the pieces of code are going to do. If I I've changed this here, right? So I'm doing this, and then I'm doing this, and then I'm doing this, right? So kind of a chain of operations. And I'm now just using white space for each method or each operation in that chain. And what that allows me to do is comment out one step. And so what I'm going to say now is, okay, please load this up and select stable lights, but don't rename it yet. And what you see here is that you have an image that has a band, stable lights. And that is gonna, if we comment out select, you can see that what we have is an image that has 4 bands. So by saying select, we're saying, hey, please just focus on this band and select this band from the image and don't bring over the other ones, or don't load up the other bands. And then here, what we're saying is, now that you've grabbed the band that I want, please rename it to something that is going to make sense in a second. But we're going to rename it after the year that it represents. Is that okay? So then we basically go through that routine again. And so now we're saying, all right, let's make grab another image. We're going to call this one lights 13. We're going to select the stable lights and we're going to rename it 2013. And before I even run that, let's just look at it. Say print lights 13 and run it. And so now what I have is, again, an image, and we can see by the ID that it's from 2013. And we can see here that it's got one band, and that band is going to be stable lights. It's just that we renamed it 2013. So now what I'm going to do is take these lines. The lines we may not be in complete agreement about our line numbers anymore, depending on how the white space and the print commands and so forth. But I'm going to uncomment from construct an image with 3 bands down to this print statement. And I'm going to uncomment that and I'm going to run it. And so now what I'm getting is, I said, please make a new variable called change image, and it's going to be constructed from lights 13. So this thing that I made here that has a one band called 2013, and then add the bands from lights 03. So we're basically saying, take this band 2013, so make a new image, and in this image stick this band from 2013 followed by this band from 2003, followed by lights 1993, but select the stable lights and then rename it 93. Because remember, here we have 4 bands still in this image that we constructed at the start, right? And so what we're asking it to do all at once is create a new image that is going to grab just that stable lights band from 93 and then rename it 93 and then stick it with these other 2. And so when we print our change image down here, what you should see is that we now have a single image that has 3 bands. The first one is 2013, because that's the one we started with. The second one is 2003, because that's the one we added second. And the third band is 93, because that's this thing where we've selected the stable lights and renamed it 93. So these 3 bands from these 3 images are now in a single image. Fair? And now the fun happens, because we can just say, now please add a layer that shows the data that's in this little image stack. And I don't even have to tell it what bands to select or what bands to visualize, because there are just 3 bands in this image. And then I'm saying the minimum value is 0 and the maximum is 63, because we know that from, we looked at that previously when we looked at the band information there. And then call this thing the change composite. And when you run it, what you now get is this, what I think is a really interesting image that is showing you the it's showing you basically this information over 10-year intervals using additive color to represent the brightness of the lights in each of the image. So let's go through what we did here. We used the first image in our stack, 2013, is going to be displayed with the red channel. The second image in the stack from 2003 is going to be displayed with the green channel. The third image in the stack, 1993, is going to be displayed with the blue channel. So what does this mean? Well, if we grab the inspector and you click around on the white part of Shanghai, what you should see in our chain composite is that it's white because the lights were bright, kind of at the maximum value, 63, in 1993, and then 10 years later in 63, and then 10 years later in 63 again. But when you get a yellow color, and so if we zoom in and find a nice yellow pixel, I'm going to ask it not to show that underlying one so that it just draws a little faster. But if we take one of these yellow pixels, what we should get is it was not very high in 1993, but it became bright in 2003 and then became even brighter in 62. And so when red is high and green is high and blue is low, the result is yellow. And then if we cruise out and look at a red zone, so let's look out into one of the red areas and click on one of these pixels, what you should see is a place that was low in 93, pretty low in 2003, but became bright in 2013. And so it's showing you this kind of sprawl pattern that you get kind of over and over again, where you get the core that was developed and bright over all three time steps, and then how it kind of sprawled and grew from that core outwards. And then this can be fun to explore. You have when you have a blue color, it's suggesting a place when you click on it that was highest in 93, but then lower in the years following it. And a green color, similarly, is going to be should be higher in the highest in the middle step and lower in the other two. And this kind of aurora pattern that you see in the Korean Strait is could be boat activity, like the fishing fleets for squids that use halogen lights could be appearing there. You over in the U.S. you get this kind of a red giant pattern, I think of it, where it's a big splotch of over a large geographic region, where you have, if you click on the red pixel here, you have a place that was, again, pretty bright in 2013, but not bright before that. And if you go and look at some of these locations, this is some of the fracking activity or this is from fracking in North Dakota, or in one of the Dakotas. It's getting late. You see the tar sands up here, but it becomes a kind of a beautiful image to explore in a humbling way. You'll see political boundaries that are shown, and there's some changes in Syria, and it becomes, I think, a really kind of interesting image to explore, and a helpful one to begin to learn how additive color works. So let's go back to here and see how I'm doing on this. So we talked about the stable lights at night. We talked about this RGB composite. And then again, I've made this kind of an app that can be fun to explore this image, where it will allow you to pick an example, and then again we'll start picking sure. And then the idea is that if you zoom in and you click on a location, it'll give you the chart that shows you the change in the brightness at that location that you clicked. And I have this linked so that you can use the additive color slider to kind of interpret that this image. I use this to try to help students begin to learn how additive color works. And the source for this is this data set, as we talked about. And then there's more information here if you want to see a little write-up. And then this will bring you around. So the holiday lights is another example of that tends to come from resource extraction and oil and natural gas activity that's more focused and localized. And you can usually see it if you zoom in onto the underlying imagery. And so I think those are all the tricks that I know. So additional resources, these are links to the Earth Engine user guide for image visualization and image information metadata. For band combinations, these are just some links to resources that are on the web for picking appropriate RGB combinations. This one comes from the American Museum of Natural History, and we'll kind of talk about Landsat thematic mapper combinations. There's another one, Portland State, I think has a guide that's been up for a long time that I found very helpful. And USGS also has some information on band combinations. And then for me, this is a GitHub page that has some of the projects that I'm working on. And then if you're interested in, if you would like to be able to create your own histogram to explore stretch enhancement, this is a little starter script that will help you do it. So displays data values in one band from an image scene. So this, I believe, is working for, I just add to it and say map, add layer, image, and bands SRB1. And then this is that's probably all about I need. And if I click run here, it should display that image that we're interested in or that we've been using in the demo. And you can look at the histogram and then change the values here. Sometimes Earth Engine does this to me, and I don't quite know why. It makes it difficult for me to add a new line. But if I say min 8,000, max 12,000, and run it, I can look at, and you can kind of play with your own kind of stretch enhancements that way, or contrast enhancements by adapting this script. But the basic idea is that's how you make the histogram. You feed it an image, you tell it the band that you want to look at, you give it the resolution of the image, you say what color you want to show in the chart here, and you define the minimum and maximum. And if you start from scratch, you would start from 0 to 65.5, something or other, and that'll show you the tower. And the trick is to go from the Midtown Tower to a to some kind of a nice nice hill, and that's how you do contrast enhancement. Okay, so I think that just about does it. And let's see.